to understand big omega, we will proceed same approach, same steps what exactly we done for to try to understand big O. Okay, so just for example, for our understanding, let's take f of x equals to same function what we used for big O. So 2n plus 3, right? This is our f of x. So same function we used while trying to understand big O. So now we will try to understand by using same function, okay, for big omega. So we know how to plot this in a graph. We already done this in while understanding big O, but to clear us, we will try to repeat the same thing. We will try to plot the graph for this 2n plus 3 in x-axis and y-axis. So this x will be n. So this will be the input for your function, and this will be the time. Okay, this is your f of x. This is your time. So let's try to replace n value 1, 2, 3, 4. Okay, let's place one value 2n plus 3. 2 multiplied by 1 plus 3. Let's place 2. 2 multiplied by 2 plus 3. 3. 2 multiplied by 3 plus 3. 4. 2 multiplied by 4 plus 3. So this means 2 multiplied by 1, 2, 2 plus 3, 5, 2 2s are 4, 4 plus 3, 7, 2, 6, 6 plus 3, 9, 2 4s are 8, 8 plus 3, 11. So let's plot these values, 5, 7, 9 and 11. So when I pass one value to this function, what I got? I got 5. So my dot will be here. For 2, 7. So this is my 2. 3, 9. For 4, 11. Right? So if I go like this, this is my line graph of f of x equals to 2n plus 3. So now we are able to draw a graph based on our given function. Now the same steps we will try to do what exactly we done for big O. So big O, as we discussed, big O will appear in this graph. What is the place for big O? This is the place for big O, right? So big omega is one of the representation to represent our time complexity or complexity of your algorithm or complexity of your program, right? So this is another way of representation, same as big O. So now for this function, we able to find the graph for this. So now what exactly we will do? We will do the same steps what exactly we done for big O. So what exactly we done for big O? Can anybody tell? Can anyone tell me what exactly we discussed and we learned? So yeah. So while finding big O function, we first try to find another function g of x that will be multiplied by a constant, positive constant c value. So this value is always greater than or equals to f of x, right? So for given n0, right? This is what exactly we learned about big O. So now in the same way, what exactly we will do is we will try to find a function g of x. In big O also we will try to find another function g of x. So we will try to multiply a constant, positive constant c value, that can be any positive number. So the main point here is we need to find another g of x function, and when you multiply with a positive constant value, this after computing this value should be should be less than or equals to f of x. So let me rewrite this. So f of x is always greater than or equals to g of x multiplied by c. So this is for given n0 if there are positive c value and n0. It is same as big O notation, but the only change here is this. So previously for big O, what is this? Lesser than or equals to. Now for big omega, it is f of x is greater than or equals to g of x multiplied by c if there is any positive constant positive number c and n0. Okay. For example, if I have f of x, then what will be my g of x? I need to, what will be my big omega? Big omega will be this. And c and n0 will be positive integers. So now, before going to this, what exactly we will do? We will try to find another function. Okay, we will try to find another function, g of x, such that g of x when multiplied with some constant, what exactly we need to do? We need to find g of x first. So, for example, my g of x equals to, this is my f of x, and I want to find a function. That function always produces my graph. When I multiplied with some constant, positive constant, I want to find a function g of x. And when I multiplied with a constant, positive constant, what I am expecting, this value, this entire clause should produce me another line that should plot on this or below this. So the area of big O function will gives us on this or below of this line. So whereas when we learned about big O area is upwards. This. Now what exactly we are trying to find? We are trying to find a function when we multiplied with some positive constant number. I am expecting a line that should fall below this line or on top of this line. That is what we are trying to find. So first I need to do that, I need to find a g of x, right? So my g of x, let's try for this randomly. We can try as we tried. So while trying for big O, what exactly we done? We done 2n plus 3n. So we used this kind of function for big O notation. Now what exactly we are trying to find? We are trying to produce a line that falls under this area. Means this function g of x should produce the lesser value compared to f of x, right? That is our core idea. So let's imagine, let's 2n, just keep like this. This, what it will give. So if I place one value, for 1 it is 2, for 2, 2 multiplied by 2, for 3, 2 multiplied by 3, for 4, 2 multiplied by 4. So 4, 6, 8. So for 1, for f of x given me 5, here in this case 2. For 2, f of x given me 7, but here g of x giving only 4. So these are, if you observe, these are values are lesser than compared to my f of x value. You can take any, we can represent this in any format basically. So I previously whatever discussed 2n also will be produce proper result, but I am taking 4n plus 1. For example, I am choosing 4n plus 1 is my c of x, g of x. So what will this function will produce? So let's imagine, if I replace one value here, if I replace 2, if I replace 3, what will be the values? If for 1, 4 multiplied by 1 plus 1. For 2, 4 multiplied by 2 plus 1. For 3, 4 multiplied by 3 plus 1. For 4, 4 multiplied by 4 plus 1. What exactly this is producing? Let's see. 4 plus 1, 4 plus 1, 5. 4 plus 2, 8. 8 plus 1, 9. 4 plus 3, 12. 4 multiplied by 3, 12. 12 plus 1, 13. 4 ja 4, 16 plus 1, 17. If you observe these values, so for 1, both are same. My f of x and g of x are producing same value. But whereas when I am passing 2 value here g of x, I am getting 9. But for f of x, my value is 7. That means what? This line, if you plot this line will come here, not below this. So we can't choose this function. So whatever function you are going to choose, that function should produce a line below or on f of x line. Right? This area belongs to big omega. This area belongs to big O. Okay? So now, because this function is producing higher values compared to f of x, then we need to change this such a way it should produce the lesser value compared to f of x when I plot this in a graph. Okay? So let's imagine I picked randomly another function g of x equals to n plus 4. Now let's see what will be my output, whether this will be sufficient for to find a lower bound of this line or not for f of x. Let's replace these n values with these values. For 1 plus 4. For 2 plus 4. For 3 plus 4. For 4 plus 4, right? So I am just simply replacing the value. 1 plus 4, 5. 2 plus 4, 6. 3 plus 4, 7. 4 plus 4, 8. So now let's plot the line for g of x. So we have another constant, right? G of x multiplied by c, some positive constant. So in this case, as we done in big O also, let's imagine c is 1 only, positive constant c. What will be happen? This is my c, this is my g of x. Okay, c is 1, I will get the same result, 5, 6, 7, 8. Now we will try to plot this g of x multiplied by c in this graph. Okay, so now for 1, what is my output? 5. So if my input is n, then what is my output? 5. So same as f of x, right? Same as f of x. Now if I pass 2, what is the value for g of x multiplied by c? 6. 6 somewhere like this. So if 2, it will come here. For 3, what is my output? 7. If I pass 3 to my g of x multiplied by c, what is the value I got? 7. 7 means here it is there. So for 4, 8. For 4, 8 somewhere, 8, 6, this is 4. So for 4, what is my output? 8. So 4 is here. So my 3 is here. My 6 is here. So if you observe, this is my line, right? So this is my f of x line. This is the line of my g of x multiplied by c, right? So if you observe, so this clause giving us, this clause is making us always f of x is greater than or equals to g of x multiplied by c, right? This is satisfiable by using this n plus 4 multiplied by c with this g of x multiplied by c. See, now here C is positive constant, right? So if you observe, for 1, when I pass 1 value for my f of x, what is my output? 5. If I pass n value for my g of x multiplied by c, same value I am getting. So this thing we will call it as n0. So we will say this will be satisfiable if and all if I have a positive constant c and n, okay, and that n is greater than or equals to n0. It is same as big O, right? But the big O and the big omega, what is the difference? The difference is this one. If it is big O, it is lesser than or equals to. If it is big omega, it will be greater than or equal to. So now, what is my n0? N0 is this one. 1. 1 is my n0. Right? So after 1, if I pass any value, after 1, 2, 3, 4, 5 or whatever it is, the g of x multiplied by c always produce below the value of my f of x value. Right? That is what exactly it represents. So now if you observe, this line is my f of x, this line is my g of x multiplied by c, and this satisfying this condition, f of x is greater than or equals to g of x multiplied by c. Okay? Now, so what is my this function g of what is my f of x? My f of x equals to 2n plus 3. Okay, so this is always greater than or equals to what is my g of x? G of x n plus 4, right, multiplied by what is my c? Constant 1, right? So this is g of x, this is my constant. For n is greater than or equals to n0, here it is 1, right? So this is big omega. So big omega always falls below the line of f of x, or same line can be fall. So here we can represent this in another way. I will erase this. So my f of x equals to 2n plus 3 is greater than or equals to always greater than or equals to n plus 4 and multiplied by c, that is 1. This is positive constant, where my n is greater than or equals to n0, that is 1, right? That is 1. So now, what is my g of x multiplied by c? N plus 4 multiplied by 1, right? So what is the degree of, highest degree of n here? We can mark this as n power 1 also, right? We can represent this as n power 1, right? So that I will get the degree of here n is 1, right? So as I already explained, why we won't consider these 4 and 1 values. Why we are only considering n value? Because there is some reason. I already explained, and one more time I will explain. See, because when you go through this line, when you plot this line, go on for these inputs, if you change inputs, what it will happen, the significance of these 4 and 1 will become very less when n increases, right? So when, for example, if my n is 1 lakh, or if my n is 1000 or 2000 or 10,000, so what is the significance on my, this 4 and 1 won't signify actually. If my n increases, the significance of these constants will be very less. That's why we eliminate them, as we did in big O also, right? So now if I remove them, I won't consider while calculating big O, finding big omega or big O or big omega, Only our concern is what is the highest degree of my n. So in this case, what is my highest degree? N power 1. So this can be translated as, for this f of x equals to big omega of n. Because my degree is 1, so I can represent this as big omega of n. Right? So we already found what is my big O of this function. F of x equals to big O of n. We already done this in last class, right? Now we found what is my big omega of my this f of x, big omega of n. So now we will write down the equation. We will translate this graph and these equations into one text format so that you people can understand. So the definition of big omega is this. What exactly this is saying? This is the same replica of translation of what exactly we done. We found first for given f of x, we found g of x and we multiplied with a c constant. That clause always produces the number less value compared to f of x. For given, for n is greater than or equals to n0 and n0 and c are positive numbers. So let's read this out. The function f of n equals to, this is big omega. This is the function f of n equals to big omega of g of n. We can represent this. For this f of n, this is my big omega of g of n. If there exists positive constant c and n0 such that f of n is greater than or equals to c multiplied by g of n for all n is greater than or equals to n0. So in our case, what is our f of n? F of x or f of n? 2n plus 3, right? This is my f of n. So what is my constant? 1. What is my g of n? N plus 4, right? This is what exactly. So this value is always greater than or equals to when you multiplied 1 with n plus 4. This is c multiplied by g of n for n is 1, right? So this is what big O of for given function. So in our case, how can we represent this like this? So my f of n equals to what is what? Big omega of n. That is what we came to conclusion in the last, before writing this, right? So this way, that means for 2n plus 3, this is my big omega of n. So this is, we will say, lower bound of this function. Okay? This is not about worst case or best case or average case. As we said, as we learned, these are the one of the representation for your representing your complexity of program. So it is like big O, it is big omega. These are two different types of representations of your complexity. It is not about average or best case or worst case or nothing. So this is my function f of n equals to 2n plus 3. So we know these are the known functions till now. This is constant, this is log n, root n log n power k and k power n. This is polynomial and this is exponential. We learned about these things, these functions earlier. So now for this function, what is my big omega? Big omega of n. Right? This is what exactly we found. What is the place of this? So here it is there. Right? So what is my big O? big O also, for this function what is my big O? Big O also n, right? Same place. So now observe from here onwards, this n log n power k power n or combination of this always represents big O, right? If you use these functions in g of x, you will get always greater than or equals to your f of x. That is what big O. So from n to here, if you use one of these functions, it will produce your big omega, right? So this from here n to go on, this will represent big O. When you come here to 1, this will become your big omega, right? The both things can be represented as n, right? This is the n. This can be represented as your big omega, and this can be represented as big O, right? So for this function, this is my big O and this is my big omega, and I can say not only n log n also big O of for this function. N power k also can be one of the big O representation of for this function. Not only n power k power n also can be represented as big O of for this function. In same way, root n can be my big omega of this function, because if you use previously what exactly we done, n plus 1, right? So this is my g of x. So instead of n, if I replace n with root n plus 1, this will also, if I multiplied with the c constant, this will also produce lesser than value compared to f of x. So I can say root n also can be my big omega of root n. So we can say log n or 1, right? So in these functions, these things can be represented as big omega, and these things can be represented as big O. In this case, for this function, n can be your big O and big omega also, right?